Hello guys, welcome to another episode of Set. So this is the part 3. The part 1 and part 2 will be linked in the description. So in this video we're going to be discussing about exercise 1.3, especially about subset and all those things. So let's get started. So what exactly is a subset? So if I say A is a subset of B, or it is subset is denoted by if I call A is a subset of B, which means every element of A is inside the B, which means every element of A is inside the B. Okay, let's try to understand using this an example. Let's say your A equal to 1, 2, 3, and your B set B is equal to 1, 2, 3, 4, 5, 6. If I say A is subset of B, which means every single element of A is there inside the B. So you can see A has 1, 2, 3 as its elements, whereas B has 1, 2, 3, 4, 5, 6. Thus, this element is there in B? Yes. So I can say A is the subset of B. Now imagine if I have, say, C equal to 1, 2, 3, 7. 1, 2, 3, 7. Now, can I say C is the subset of B? Let me just check. So, is 1 is there? Yes. If 2 is there? Yes. 3 is there? Yes. Is 7 there? No. 7 is not there. So, from this, I can say C is not a subset of B. So, subset is basically if every single element of this is there inside the big set, which means it is a subset of that set. So let us try to understand more using by solving exercise problems. So the textbook I'll be using is Ncert textbook of 11th standard. I'll put the link in the description. You can go and download it for free. So I'm solving the exercise 1.3, problem number 1. So we have to use this symbols, subset or not a subset, in this following problems. So the first one is 2, 3, 4. Is it the subset of 1, 2, 3, 4, 5? Now we just have to check whether these elements are there in this set. If it is there, it is a subset. If it is not there, it is not a subset. So S2 is there, yes. 3 is there, yes. 4 is there, yes. So this set is the subset of that set. That's all. The next one is A, B, C, whether it is a subset of this set. So is A is there? No. B is there? Yes. C is there? Yes. So every single element should be there. If even one single element is missing, then it is not a subset. So that's why I can say this is not a subset of that set. Easy, easy. So third one is set of all x such that x is student of class 11th of your school, whereas this set is set of all x such that x is student of your school. So your school basically consists of all the standards. So it starts from first, second, third, fourth, 5, 6, all the way till 11th, 12th. So they're saying this set as all the students in the 11th class, and they're saying this set as all the student in your school. Now which is bigger set? Of course this. Now this. Now all the elements in this set are there in that set? Yes, of course, because all the students in your class belongs to the school. So of course I can say this is a subset of that set. And the next one is set of all x such that x is a circle in a plane, whereas set of all x where x is a circle in a same plane with radius 1 unit. So let us try to solve this. So the first one, they're saying circle, like every circle in a plane. So we have this plane, x-axis, y-axis, and all the circles. So basically every single circle, every single possible circle on the plane. So this is this set. Whereas this one is every single circle in the same plane with radius 1 unit. So in this case, the radius is restricted to only one unit. So say suppose 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. Only 1 unit should be the radius of the circle. Whereas in this, you can set any unit. Either it could be 1 unit, 2 unit, 3 unit, 4 unit, anything could be there. So which the bigger one? This is of course the bigger one. This is a smaller one. In fact, you can say this is a subset of this, because every single circle of 1 unit can be fit in all the circle in the plane. But this is not the subset of this. So I can say from this, it's not a subset. And the next one is set of all x such that x is triangle in a plane, whereas next one is set of all x such that x is a rectangle. X is a rectangle in a plane. So this is all the possible triangle in a plane. So triangle, 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 triangle. Whereas here it is all the possible rectangles. So all the possible rectangles. Now does this fit inside this? Does all the elements in here can occur in this? No. So from this I can say it is not a subset. Both are completely different shapes, and they don't even match to each other. So from this I can say this is not a subset of that set. So there are two more problems. So in the sixth problem, they're saying set of all x such that x is equilateral triangle in a plane. Whereas in that set, they're saying set of all x such that x is a triangle in a plane. So equilateral triangle in a plane is all the possible equilateral triangle in a plane. So this is x axis. So all the equilateral triangle which you can draw, bigger ones, smaller ones, tinier ones, everywhere you can draw. So all this possible, only equilateral triangle. Whereas in this set, all the triangle consists of, it's just all the possible triangles. Equilateral triangle, isosceles triangle, scalene triangle, every single possible triangle which is possible on a plane, it belongs to this set. So I can say this belongs to this, so I can recreate this, every single element which is there in this, I can recreate in this, because every single equilateral triangle is also a triangle. So from this I can say this set is a subset of that set. So the last one is set of all x such that x is even natural number. So let us try to write all the even natural numbers. So even natural numbers are 2, 4, 6, 8, 10 and so on. Whereas here it is all the integers. So we have integers starts from minus infinity, goes all the way up to 3, 2, minus 3, minus 2, minus 1, 0, 1, 2, 3. It keeps on going till infinity. So can I say I can recreate every single elements in this? If I keep extending this, say if I write 4, 5, 6, 7, 8, I can keep extending how much ever I want. So every single element is there inside that. So 2 is there, 3, 4 is there, 6 is there, 8 is there. I can even keep on writing all the elements which are there in this set inside that set. So I can say this is subset of that. So the second main of the third exercise is we have to state whether it is true or false. True or false. So they're saying AB is not a subset of BCA. So is this, so every single element is there. So A, yes, it's there. B is also there. So this statement is false. False. Why? Because AB is a subset of BCA. So here next one, AE is the subset of set of all x such that x is vowel in the English alphabet. So this set is basically AEIOU, isn't it? So does every element is there in that set? A, yes, A is there, yes, E is there. So the statement which they are saying is true. So this second statement is true. Third one is 1, 2, 3 is the subset of 1, 3, 5. Of course it's wrong, because yes, 1 is there, 3 is there, but 2 is not there, which means this statement is false. Now the fourth one is they're saying A is a subset of ABC. Is A is there in this set? Yes, it's there, which means I can say it is true. Easy. So here they're saying A belongs to ABC. If they're saying the set A belongs to ABC. If they would have said A belongs to ABC, which I could have said it is true, but set A belongs to ABC, it's a false statement. It could have been true if this set was like this, because this element belongs to this. So you use belongs to when you indicate the element. So this particular element, if it's there in the set like this, then I could have said it is true. But since they have given in this way, which means it's a false. So don't confuse these kind of problems. So the last problem is set of all x such that x is an even natural number less than 6. So let us list all the even natural number which is less than 6, 2, 4. 6 is not, should not take 6 because they're saying less than 6. So 6 is excluded. And this set is set of all x such that x is a natural number which divides 36. So let us see what are all the natural number which divides 36. So what number will divide 36 that are natural? So 1 will divide 36. Then 2 can divide, 3 can divide, 4 can divide, and 5 can't divide, 6 can divide, 7 can't divide, 8 can't divide, 9 can divide 36. And then next number is I think 18 can divide 36, and the next is 36 itself. So these are all the natural number which can divide 36. So we have to check whether this set is there inside that. So 2 is there, yes. 4 is there, yes. So this statement is true. This is subset of that. So now let us try to solve the third main. Now student normally make mistakes in this, so I want you guys to pay closer attention to this. So they are saying a equal to 1, 2, and then 3, 4, and then 5. So we have to find whether the statements are correct or not. So basically it's about correct, just select tick or wrong, and we have to justify the statement. So tick or wrong and justify. So whenever you have these kind of like some inside brackets, so what you're gonna do, in order to avoid confusion, you're going to call that set, like what element which is there in the bracket, as some element. So suppose I'm going to call this what 3 comma 4. I'm going to call 3 comma 4 as k. I'm going to call that as k, and I'm going to recreate this set. So a equal to 1 2 k 5, and wherever I have this kind of like say 3 4, I'm going to replace that with k, and try to solve that. So we have, so firstly we have 3 comma 4 is the subset of k. So sorry, subset of a. So what I told, we have taken 3 comma 4 as k. Also I'll replace this as k. So let's see what happens. So this is k. Is k subset of a? Is this a set? No, set is normally like denoted by like this, right? And it is not denoted like that in the question. So it's just given a, so we found it as k. So is this subset of k? No, this belongs to k. I could have said it belongs to k, but it is not a subset of k. So this statement is wrong. And the next one is second one, 3 4 belongs to a. So 3 4, I told you this bracket thing is there, we'll replace it with k. So does k belongs to a? Does k belongs to a? Yes, this statement is correct. And here we have 3, so 3 comma 4 will replace with k. So is the k subset of a? Is this set there in this huge set? Yes, k is there in that, so I can say this is true. So to avoid confusion, try to write like this, try to recreate something and then substitute in the main set and then try to solve. You'll find it more easier. So this is the trick which you can use. So 1 belongs to a. Yes, 1 belongs to a. True. 1 is a subset of a. No, 1 is not the subset of a. And the next one is 1 2 3 1 2 5 is the subset of a. Does 1 is there? Yes. 2 is there? Yes. 5 is there? Yes. So this statement is true or correct. Here we have 1 2 5 belongs to a. No, 1 2 5 is it, this set doesn't, it's not there inside the set. What they mean by saying this is it's something like this. So 1 2 and 5, like this, like whole set kind of thing is there inside the set. Now this is not how the set is. So this statement is false or wrong. And here we have 1 2 3 is a subset of a. So 3 is separately written inside a unique brackets. So this here they have written it separately, but here it is merged with 4. So this statement is also false or incorrect. So this is kind of tricky one. So please take a note on this. So they're saying 5 belongs to a. Is this inside this? Is this element is there inside this R set? No. So wrong. That's all. If it is there, we use the symbol belongs to. If it is not there, then it doesn't belongs to. So let's try to solve the 10th one. They're saying empty set is a subset of A. Yes, empty set is a set and it is a subset of A because emptiness is there inside the set. And I can say empty set is subset of A. Always remember, empty set is the subset of every single set because you can find emptiness in every single set. So this statement is true or correct. Okay, now they're saying this is the subset of A. So subset, basically every single element should be there inside that set. So is this element there inside the set? Is it there? No. So it's a wrong, incorrect statement. So the next topic is subsets of real numbers. So these are the some unique sets which are used in mathematics. So first we have natural numbers, which is 1 2 3 4 5 and so on. We have whole numbers, which is basically 0 with natural numbers. So 0, if you add 0 with the to the natural number, you get whole number. So 0 1 2 3 4 5 and so on. And then you have integers, so it comes all the way from infinity and all the rounded off numbers, so including all negative and positive ones. So you have -3, -2, -1, 0, 1 2 3 4 5 6 7 till infinity. It goes towards the back also, -3, -4, -5, -6. In this way also it goes, basically all rounded off numbers. So then you have rational numbers. So this is rational numbers. So rational numbers, so this is integers, this is whole numbers, this is natural numbers. So you guys probably know rational numbers are the one which could be expressed in the form of p by q, where this denominator couldn't be equal to 0, which is q is not equal to 0, and p and q are integers. So basically every single number which you can express in the form of fractions. So that is rational numbers. So then we have irrational numbers. So irrational numbers are the one which couldn't be expressed in the form of p by q. So x is not equal to p by q, where q is not equal to 0 and p and q are integers. So basically all the numbers which you could not express in the form of fractions. For example, pi, You guys know this pi x e value and all that. So the next one is R, which is real number. Real number is basically rational plus irrational constitutes real number. So set of all x is that x belongs to rational and x belongs to irrational. So T is the denotation for irrational numbers. Please remember that. Now here we can form some subsets here. Now can I say natural number is the subset of whole numbers because every single is there inside this? I can say natural number is the subset of whole number. Now can I say whole number is there inside integers because every single number is there inside the integers? So I can say W is the subset of Z. So I can continue W is also a subset of Z integers. Now can I say every single integers could be expressed in the form of P by Q? I can say every single this could be expressed in the form of fractions. Can I write 2 as 2 by 1? Basically in the form of P by Q. Can I write every single number as that? So I can write 3 minus 3 as 3 by 1. It's basically minus 3. So every single number in this could be expressed in the form of P by Q. So I can say Z is also a subset of Q. So Z is the subset of Q. I can write. So this is the thing. So T is a unique set. So we don't need to include on that. So also I can say that since a real number is the combination of both rational and irrational numbers, can I say rational number is the subset of real numbers? So rational numbers are subset of real numbers. Also, irrational number is also a subset of real numbers. So I can say that real numbers is basically every single number possible. So you take the number line, if you're confused what is real number is, so you take the number line and so whatever the numbers you locate on the number line, 1.1, 1.2, every single number which is there on the number line constitutes for real number. That's why we call this number line, what we use for graphs and all the mathematical operations, that's why we call this as real number line. Real number line, because every single numbers could be expressed in this line, so that's why it's called real number line. So every single rational number is there in this line, so that's why, so I can say every rational number is a subset of real numbers, and every single irrational number is also there in this line. For example, 1, 2, 3, 4. So 3.14 is something somewhere over here. 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9. So E is also, so E value is 2.71, 8, 2, 8, 1, 8, 2, 8, 4, 5, 9, 0, 4, 5, 2, 3, 5, 3, keeps on going. So can I say this number is also going to be expressed in this? So 2.71, it's going to be somewhere here. So what I'm trying to say basically is rational number is a subset of real numbers. Also irrational number is a subset of real numbers. So this was basic number system which you need to know. Now let us try to understand intervals of real numbers. Okay, now let us try to understand intervals of R. Intervals of R is basically a section in real number line. So we have this real number line. So 0, 1, 2, 3, and all the numbers in between. So -1, -2, all the way up to minus infinity, all the way up to plus infinity. So intervals of R is basically a part of this number line. So this bracket is used to indicate the closed interval, whereas this bracket is used to indicate the open interval. Let me explain. So you have this first one, which is called, so you have both open intervals and these two numbers. So it's basically, the meaning of that is set of all x such that x is where a greater than x and less than b. So how do you write this in terms of example? So let me give you an example. So x is say 2x 9. So this is how we write the two open intervals. So if you have only greater than but not equal to, you're going to write using curly bracket here. So if you have equal to, you're going to use box bracket. So for this, the example is, say I can use the same thing. So if the boundary numbers are included, you're going to use the closed interval, which means they're included. So if the boundary number is included, so here the boundary numbers are included, so that's why you should use this box bracket. If the boundary numbers are not included, you're going to use the curly bracket. So if you want to write this in number line, you could express like this. So you have a number line like this. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're saying 2 and 9 are not included, so we have to start with 2, end with 9, and you don't have to circle those dots, and all the numbers in between 2 and 9 is there in this interval. So this set you can express in this form, and meaning of that is basically all the numbers between those two, excluding those two boundary numbers. So for this we can write So this could be this we can express in the number line like this. Same thing, 0, 1, 2, 3, 4, all the way up to 9. So here we are including 2 and 9. We are including the boundary numbers. So we have to shade that. So you have to shade that and then include all the numbers in between those, including the boundary numbers. So this was basically the meaning of this intervals. So for this one, it's basically one side is open, other side is closed, which means you have to include this, exclude that. Let me do the example for this also. So set of all x such that 2, 9. So this could be expressed in the number line like this. So we have 0, 1, 2, 3, all the way up to 9. So we have to exclude 2. We have to exclude 2, which means I have to write a circle on that. And on the 9, I have to include 2. On the 9, I have to include 9. So I'm going to shade that number. And all the numbers in between are going to there inside your set. So if I write curvy here, which means that number is not included. And if I write box, which means that number is included. So basically, that it's that easy. Whereas for the last one, it is basically the inverse. So it's going to be like this. The example is, so in this case, we're going to include 2 and exclude 9. So 0, 1, 2, 3, 4, all the way up to 9. And in this number line, we're going to exclude 9 and include 2 and all the numbers in between. So this was intervals of real number. So we basically came to know what is the meaning of the intervals. So if you want to express, in this form, if you want to express this in this form, it will be written like this. So you have to write curly bracket, which means 2, this number is not included. So 2 is not included. That's why I'm going to write curly bracket, comma 9. And you have to write curly bracket for that also, because even 9 is not included. For this, since 2 is included, so box bracket for 2, and then 9 is also included, so box bracket for 9 also. And here 2 is excluded, which means curly bracket for 2, and 9 is included, so box bracket for 9. So for this, box bracket for 2, because 2 is included because you have equal to sign here, whereas 9 is excluded, so that's why I'm going to write curly bracket for that. So this was how you understand the intervals of R. And there is one more thing called length of the interval. Length of the interval is basically length of the interval. So if you have, you'll be given these kind of intervals, and if they ask you to find the length of the interval, you just basically have to do this minus this, just b minus a. That's all. So in this example, the length of the interval of this is, so a here is, so this is a and this is b. So 9 minus 2, which is 7. So length of this interval is 7. So this was the intervals of R. Let us try to solve some problems on this. And now we're going to discuss the next type of set, which is power set. Power set. Power set is basically collection of all the subset of a given set. So collection of all the subsets of any given set. So let's try to understand this using an example. So imagine you have A equal to 1, 2. So what are all the possible subset of A? So one is obviously null set is a subset of every set. So we have null set as a subset. And then we have 1. So 1 is also a subset of A. 2 is a subset of A. And then this is also a subset of A. As I told you, every set is a subset of that set. So this is also a subset of A. So you can see every single element is there in that also. So I can see these are all the subset of A. Now if I collect it and write it as a whole set, so if I collect and make it a whole unique set, this I can say as power set of A. So power set of A is just collection of all the possible subset of any set. Now how do you find the elements in the power set? So in this case we found the number of elements here is 1, 2, 3, 4. So there is a formula for finding that. So number of elements in a power set of any given set is found by using the formula called 2 power m, where m is number of elements. So in this case we have 2 elements. So let us try to put, so 2 power 2 is 4. So we got 4 elements here. Let's say imagine you have so if you have this set A is equal to 1, 2, 3. So how many elements are there? So what is the number of elements in the power set of A? So you can find like by using this formula. So here m equal to 3. So n power of A is 2 to the power 3, which is 8. So imagine now you have 4 here. The number of elements here becomes 4. So instead of 3, you're going to put 4, and number of elements in the power set is starts becoming 16. So it starts growing exponentially. So this is the meaning of power set. And the next thing you need to know is universal set. Universal set. Universal set is basically the huge set which consists of every single sets. So for example, we just saw the real numbers. So you saw real numbers is like a big set which makes up every single set inside that. So I can say uh, real numbers is a universal set for all the numbers. Let us try to understand further using an example. So suppose I have a equal to 1 2 3 4 5 6 7 8 9 10, and then I have b equal to 1 2 3, c equal to 2 7 8, d equal to 7 9 10, e equal to 1 3 5 7 9, f equal to 2 4 6 8 10. Now by observing all this, can I say b is there inside this, c is there inside this, d is there inside this, e is there inside this, f is there inside this? So in this case I can say a is acting like a universal set. So universal set is basically the mother of all set, in which every single elements of the given set will be there inside that. So this was the theory for this particular exercise. Now let's try to solve the problems on that. So the fifth problem of exercise 1.3 is, how many elements does power of a has if a is equal to an empty set? So how many elements does an empty set has? 0. So what is m? M equal to 0. So number of elements in a power set is the formula 2 power m. So if m equal to 0, 2 power m or 2 power 0 equal to 1. So this empty set has one set which is that itself. So if you want to write power set of a, it's basically phi itself. So that's the answer. And the next one is write in intervals. So we have this set of all x that x belongs to real numbers and the x lies in this range. So easy way of solving this is just write the range, write the two numbers in the range, and if equal to sign is not there, use the curly bracket, and equal to sign is there, use the close bracket, box bracket. That's all. And for this, just write the boundary numbers first. So here, is it included? No. Curly bracket. Is it included? No. Curly bracket. That's all. Here, write the boundary numbers 0 and 7. Whether 0 is included? Yes. So box bracket. Is 7 included? No. Curly bracket. That's it. The last one, 3 comma 4 is boundary numbers. Is it 3 included? Yes. Box. If 4 included? Yes. Box. That's all. So the seventh one is, we are supposed to express these intervals in set builder form. So we have 3 comma 0. So how will you express in this in the set builder form? So the basic thing, set of all x, so these are all real numbers, so x belongs to real numbers, and start writing the interval. So just write x in the middle and write these two inequalities and write the boundary numbers. Okay, after that, if curly bracket is there, then leave it as it is. If box bracket is there, put a equal to sign there. So here both side curly bracket is there, so I need to put equal to sign. So the next one, so basic thing is set of all x such that x belongs to real numbers, write the boundary numbers, and is 6 included? So box bracket means it's included, so equal to. Is 12? So box bracket is there, so which means 12 is included, so equal to sign for this. So here basic thing, set of all x such that x belongs to real numbers, and then boundary number 6, 12, and is 6 included? No, it's excluded, which means curly bracket is there, so no equal to sign. 12 included? Yes. Box bracket? Yes. Then the next one, set of all x so that x belongs to real number, and then 23 5. Now is 23 included? Sorry, minus 23 included? Yes. So equal to. So if is 5 included? No. So that's why no equal to sign there. And the last one, what universal set would you propose for each of the following? So these are the two given sets. What universal set if I propose, will these two set will be belonging to that? So the first one is set of all right triangles, set of all isosceles triangle. So what set if I frame does these two both set will include in that? Set of all triangles. So if I say set of all triangles as my universal set, I can say like this will be contained in this also will be contained in this. So this set will act like a universal set to these two sets. So this was the last second one. So let us try to solve the last one. So the last problem, for the given sets A equal to 1 2 3 4, 1 2 3 1 3 5, B equal to 2 4 6, C equal to 0 2 4 6 8, we have to choose the universal set. So which among these four sets will you can choose as universal set for all these three sets? So let us see with the first one. So 0 1 2 3 4 5 6. So as I told you, universal set in which all these sets should be contained in that. It's like a big mother of set which in which all the small sets will be combined in. So 1 2 3 1 1 3 5 is there, 1 3 5 is yes, 2 4 6 is there, 2 4 6 yes. So 0 2 4 6 8, 0 is there, 2 is there, 4 is there, 6, but 8 is not there, so we can't choose as our universal set. Then 5, of course you can't, empty set. So the next one is 0 1 2 3 4 5 6 7 8 9 10. So 1 3 5 1 3 5 yes, 2 4 6 2 4 6 yes. Then 0 2 4 6 8, 0 2 4 6 8 yes, I can choose this as my universal set because all the numbers, all the elements in that in those three sets are there inside this. So this is a universal set of that. Let us check with this also. So you have 2 1 1 3 5 1 3 5 yes, 2 4 6 2 4 6 yes, 0 2 4 6 8, 0 is not there, so I can't choose this as my universal set. So this is going to act as my universal set. So this was the end of the video. If you learned something new, make sure to subscribe to my YouTube channel and hit that notification bar, and I meet you in the next video. Thank you.